for that.
I'm going to send the link of the Hangout on the mailing list, so whoever wants to join will be just clicking the link. Okay, it would be better if we all show up in the camera, so at least people know who is speaking. Doesn't go away. Okay, I can live with that.
Let's turn it over. This camera's not very good. We should use a different machine that has a better camera in the future.
Sure. Okay, for the meeting today, we have two talks. One is to you please help me. Yuguang present a project proposal. It could be just a project, or it can even grow up as a research goal. And if we have GSoC students join the broadcast, we are also going to save some time for questions. We may not be able to reply all, but we will try to reply at least a few as time allows.
Are these archived, these talks?
Yes.
So we're going to store them?
Yes, we can, and people can watch it later.
Okay.
Can you open the proposal document I prepared?
I think it would be better if you join the Hangout, open it, because you can share the slide with everyone.
Sure. Okay.
Yeah, that would be good.
So I need a power because people kind of runs off.
Do you have the? You definitely have power.
Slide down when we go back to our order.
I will invite you for the event, so you can put the slides. How do I do this? Now, screen. Oh, here.
So there is a Hangout link.
And
this is.
I just invited you.
Yeah, okay, great.
So now you can.
Yeah.
The slide on the edge of the screen. Just actually mute your microphone.
Okay.
Okay. If you speak, you will take this. Oh, no, but I see. Let me select your screen. Okay.
So I prepared a proposal to running TFRC to XIA because right now I'm porting some video streaming application to XIA, and previously I had some research about rate control. So I would like to introduce this TCP-friendly rate control to XIA. So what is TFRC? TFRC is a congestion control mechanism designed for unicast unreliable flow in TCP environment. And I also think it can be applied to our XIA. So first, I would like to introduce what is reliable transmission, what is unreliable transmission. So reliable transmission, TCP is kind of reliable transmission. It's guarantee the packet arriving and their orders, and also resend the missing packages. And UDP and also our XDP principle did something like unreliable transmission. It doesn't care whether the package arriving to its destination, right? And why we bring this TFRC to video stream? Because TCP is not proper for video streaming. And if you're familiar with RTP, and people, at the very beginning, people design RTP for TCP, but later we found that TCP is not proper for video streaming because video streaming asks for smoothie sending rates. We care about time rather than the quantity. We want some smoothie video streaming, right? So this TFRC will bring congestion control to this unreliable flows and then give better video streaming.
Is there a clear reason at this point why you chose this protocol?
Yeah. So, I mean, the first, why we choose this one for our XIA. First, I think this one is a simple feedback algorithm. It is easy to implement it.
Okay.
And second one is this one, although it is simple, but it's formula-based, has some equations. We can mathematically prove it also feasible on our XIA. So it has a lot of equation. I will show you later the equation. I think all the equation I pick up from the RFC files, their proposals can be used later on our XIA. And I also have the third reason. Third reasons is that this one is called TCP friendly. So what is TCP friendly? TCP friendly is it can reach the reasonable fare to TCP connection, use no more than the bandwidth than TCP. That's called TCP friendly. We don't want to interrupt the TCP traffic, right?
Okay.
So this is certain reasons why I choose this to XIA. And I also think later whether we can use this TFRC to all the principles. So on the TCP IP, it's also used on unreliable things. I'm thinking of it can be used to all the principles as we can modify it. So this is my tentative idea about later we can use it or modify it to be some global congestion control here.
I think it's a very good idea. I mean, TFRC is very, very widely understood.
Yeah.
So it's an old protocol. I don't know if you cite the SIGCOMM paper that it was first.
Yes, I read it, and I.
Is it in this document? It should be in this document, so everybody knows where TFRC came from and what it is.
Yes, I showed it in the reference. It's if I remember correctly, it is the RFC, the third one, right? The 5348.
Reference 6, the equation-based congestion control one, right? SIGCOMM 2000?
Yeah.
Yeah, that was the first place it appeared.
Yes, and then it made to some RFCs.
Oh, I didn't know that. That makes sense. They would make it to RFCs. I mean, that's good. That's what I was going to ask about. Is I know about it very well from SIGCOMM 2000 and the early years when people started to do rate-based equation congestion control, and then applied it also to multicast. But I don't know what's happened since then. So is it being widely adopted? It looks like it is being standardized. So
yes, it's this kind of congestion control mechanism is being used to implement some DCCP protocol. It's parallel to UDP and TCP.
Yeah, datagram
control, congestion control, or something that used for video streaming and telephony is better. But I don't think it is readily used because people right now is using UDP commonly.
Without congestion control.
Yes, but DCCP gives us more high quantity of video streaming and telephony. I think in the future people will use this new protocol. For the simplicity, people use RTP with UDP, right? They don't care the congestions. We have enough bandwidth for us. So, but later.
Why did you choose to implement
TFRC
instead of going for the DCCP?
I mean that DCCP that make use of this mechanism to implement that. This one is kind of algorithm. They use some equations to prove that this TFRC is good for TCP, and we can use this feedback algorithm. And then TCP use this kind of idea and algorithm to implement a better protocol for people to use.
But I guess what Michelle's asking, the same question, is TFRC for me is a bunch of equations mostly. It tells you how fast you should go. It's not really a protocol.
Yeah.
But DCCP is really kind of a protocol.
Yeah.
So I guess Michelle's asking, should we bring DCCP to XIA?
Yes.
Or should we just bring the TFRC equations and write our own new XFRC protocol? Well, which one of those two are you proposing?
My proposal is that we need to prove that this TFRC is feasible on our XIA array. This is the baseline. If it is not good on our XIA structure, so we can't bring DCCP to us.
Can you make it clear what kind of assumption do you expect that XIA would risk break to not make it feasible for XIA? Because at least if you are controlling flows, I don't see how XIA could even break an assumption.
For my idea, this TFRC is good, is proper for XIA, but it can be somehow. Right now, we don't prove that, right? We don't make evaluation and verification yet. We don't have the user land to test this. So
I guess Yuguang might not be well placed to see the risks. I do see some risks. I mean, TFRC has to monitor round trip times and loss rates. And if either the update frequency or the measures are not good, that weakens how well TFRC will model TCP friendliness. So potentially the monitoring rates needed to keep accurate measures may either incur too much overhead or maybe too inaccurate to really achieve the goals the TFRC protocols. That's one risk. I think it's not a strong risk.
Yeah.
I would say that the risk is even smaller because I'm almost 100% sure that the DCCP has been implemented in Linux.
Yes.
So they must have a way to get the measurements
Yeah.
to have implemented that.
So I don't delve into DCCP, but I know that DCCP use TFRC.
Mm-hmm.
So what I'm concerning is here we use some throughput equations. Throughput equation is what? TCP friendly is defined by using no more than bandwidth. So this equation is TCP rate equation, TCP throughput rate equation. So is it the similar one on XIA or we can just use this one on TCP/IP?
We don't have equations
Yes,
for
we don't
XIA. That would be probably one of the outcomes of the global congestion control. We don't have tackled that research goal.
But my idea is we definitely need this because we don't want to affect the regular the legacy TCP flow, right?
Well,
we need to.
I'm not against that, but let me widen your perspective. We either could adopt that as a rule for XIA, so the whole XIA would be TCP friendly.
Yeah.
But we could as well adopt another rule that wouldn't be TCP friendly, and on the connections between XIA and TCP, there would need some adaptation to make them to interoperability friendly to both sides. So you can, both solutions would be TCP friendly.
Yeah.
Just the way you approach it is a bit different. So I don't see a problem to start with assuming that the whole XIA will be TCP friendly. I just am not comfortable at this point to state as the only way to go.
Yeah, I think an interesting high-level perspective is that XIA could be TCP aware, and if it senses that it's competing with TCP connections, it is TCP friendly. But if it knows it's operating in an XIA-only environment, it could do its own congestion control, conceivably.
Sounds good.
That still, there's a place for TFRC because in environments, legacy environments where TCP is interoperating with XIA, you have to be TCP friendly.
Yeah.
TCP friendliness was, by the way, it was a very big topic in the research community around 2000, 2002. And I think this won the Second Contested Time Award, this paper, the reference 5, for this equation-based congestion control.
And if you want to know more about the equation, I can explain this equation. This is a TCP rate equation, and we will use this equation to calculate the sending rate. So that T is the sending rate. I gave the reference here. The T is the sending rate, and the S is package size we send. And the R is RTT, the round trip time, the most famous one. The P is the loss in bandwidth. So in this equation is very simple. We're only missing 2 atoms. One is RTT, and the other one is P. For simplicity, we sometimes use this TCP timeout, transmission timeout, to be the 4 times of the round, the RTT. So
the main challenge of this equation, if you go back up to it, so this is something that's derived. TCP never had this equation in mind when it was implemented.
Yeah.
This is what comes out of TCP when you do the derivation. The problem with this equation is it's very highly dependent on this P factor.
Yeah.
So our round trip times are stable, TRTO is kind of stable, but P is something that is very, very specific to whatever network conditions are arising.
Yes.
It can be high, it can be low, it can be small, it can change over small timescales, it can be oscillating.
Yes.
It's a crazy parameter.
Yes, later I will introduce. They give us some idea about, they use the average. They
Right,
some
there's ways to
average
smooth it.
Yes, they smooth it. It's not to give unstable state, right?
Right. But some high TCP, in sort of high throughput TCP, people are trying to really get this packet loss to be very, very low, it can be extremely low. It could be 1 in 100,000.
Yeah.
And how do you estimate such small events and really accurately? Because the difference between 1 in 100,000 and 1 in a million is like a throughput difference. It's a factor of huge difference.
Yes, that's
so you're measuring extremely low events to get this throughput equation, which people interpret it as TCP is really very brittle. If you have to, if it has to estimate this P quantity, it's really a problematic equation.
So can we rate it? I mean, give some.
It just points to a brittleness in the TCP congestion control algorithm. That really, there was a very, very interesting debate back in the day about this whole equation, about TCP, and what was TCP trying to solve, and how do you get TCP to perform faster? If in order for it to go faster, you have to lower your P by a factor of 10. All these crazy things that really elaborate that TCP operating on a packet loss probability was great in the earliest days of the internet, when packet loss rates might be 1% or something reasonable, but really,
so this loss event is not package loss. It's loss event is something between the package loss.
It can be interpreted as an instantaneous bit being lost.
Yes. There can be a lot of package loss in one loss.
Or it could be an entire event of losses.
Yes.
It's a time when a queue fails, basically.
Yeah, yes. We don't care about the package loss. This loss event it might be consist of a lot of package loss.
Yes.
So
whatever it is, it's something that causes TCP to go into timeout.
Yeah, yes, probably. Yes, sure.
So the signal is a packet loss.
Mm-hmm.
Could be many. Yeah. Or packets that are badly delayed.
So trigger. So that's what I'm thinking. We can do some research on it and modify it to be better, and then
that I'm not so sure about. I mean, this has been so intensively studied that unless we want to become congestion control experts and go and explore the extensive research here, I think the time has passed for that. That was a great topic in 2001.
Yes, I mean that. Can we bring it to XIA? Because XIA don't have this right.
I think we can bring it to XIA. I think it is reasonable to bring this thing to XIA, but I don't think it's reasonable to do a lot of congestion control.
Yes, I don't want to do much about this equation because I read the paper. I gave the reference at the very last about this equation. It's very, very difficult. If you're familiar with TCP using Windows control this congestion, right? It's very difficult to get this equation. So what I'm consider is whether we can use this equation and bring this concept to XIA and make access better.
I support that. I think from an engineering project, bringing TFRC rate control into XIA makes sense and support it. Advancing the research agenda and doing something different with TFRC or advancing TFRC research, I don't see it.
Okay.
I used to work on congestion control. It was a great topic, but I don't know. I just don't think it's a good one to work on anymore.
Yes, it's really hard.
Really hard to publish something new in the space of congestion control. Yes. Or even to do something, let alone publish it.
Yeah. So maybe we made it to a project, not research, right?
Yeah. So, bringing this rate-based congestion control to XIA makes sense.
Yeah. So this is the equations, and later we will check the behavior of how the data sender and data receivers. So what should we put in that data package? So I have a question about, can we put all these things in the XIA package? So it's just sequence number about the packages, and the second one is timestamp the exactly time we send the packages, because we want to use this parameter to calculate the RTT, right?
Let me take advantage of your question to reply as a question to motivate you to think from the XIA perspective. How do we bring evolution into XIA? It's a question.
You want to bring?
What's the only way we can make XIA evolve? There's only one way. So it's a good question. but it's a simple answer.
Can I know the answer? Sorry.
You package your idea as a principle.
Oh, okay.
The only new way to bring...
Oh, yeah.
That's the unity of evolution.
Right. Yeah, yes, we don't... We use principles.
Oh, it's...
Rather than ask, can we do it, think, can we define a principle to provide that functionality? You don't need to ask Michelle. If you can think of a way to define a principle that brings this functionality to XIA,
done.
You did it.
Yes, maybe that's the list.
Yeah, Michelle's not in charge. Anybody's in charge. Anybody who can bring a principle in.
Yeah, that's the point.
So can you define a principle with that stuff?
Yes.
Sure. There you go.
So
you all authorize that.
Yeah. Good, we solved this, right? We can do that.
Absolutely.
Yeah. So.
I mean, there's nothing. Everything's just data fields. So yeah, sure.
Yeah. Yes. So I read that RFC 5348, and it gives much more information about that. I just pick up the information I think is useful for implementing.
I think to start with it is to be less ambitious. For example, you just start with a small principle, try to accomplish everything you need in a small setting. Once you get the thing running, then you see, okay, what did I had to limit to make this run that now I would like to remove, and gradually growing it. So you do it more incrementally. Because if you try to just target the full-blown solution as the first step, it will be way hard, and you may not be able to get to some milestone that guide you to do the following steps and get lost.
So that's
let me just pause there. Google Summer of Code people, if anybody's listening, this is John Byers. I just wanted to make an important point that came up in this conversation that might be relevant to you. We're discussing how to bring new functionality into XIA, and Yuguang is proposing bringing this rate-based equation congestion control into XIA in the TFRC style. And he was wondering, can we bring this to XIA? And he has some specifications here, which he's listed. And Michelle's counter answer is, well, if you can define a new XIA principle to encompass this functionality, then of course you can bring it to XIA. So it's an easy question to answer. And since these fields are just data fields that are carried in packets, we could easily define a new principle to support this in XIA. So the answer to that one seems to be yes. So this is something for you guys to think about too. If bringing a new functionality in XIA entails defining a new principle, then that's relatively easy to bring to XIA. That's the main point, one of the main points of XIA.
So that's why I want to show my ears. Here.
Yeah, it looks good.
Yeah.
I like it.
Yeah, me too.
So it's all about the behavioral data center and do this. Now this the equations for how to calculate RTT. RTT is easy to calculate. So if we have the parameters, if we have that principle, we design a principle and we can easily calculate this RTT.
Yeah, I guess you need timestamping at both ends, but every host is going to have that. The question is about synchronization. There's a question of synchronization timing, because they need to have clocks that are pretty synchronized in order to measure this T now minus T received data. So
we have a sequence number, right?
Sequence number is different from time.
Yeah.
This T is true time, elapsed time.
Oh, okay.
So the hosts would have to be synchronized with the network time protocol or something like that.
I don't understand much how those timing protocols work, but it really out of coincidence, one of our mentors is from the Network Time Foundation, so he can certainly point you out to how you can synchronize time between machines.
Great, perfect. So it's just the high level, all the equations, how we solve this. So for the practical operation about this.
Actually, I don't remember this part. So in TCP, you measure round-trip times by sending a packet, waiting until an ACK comes back, and you measure it all at the source. But TFRC measures it one-way delays, right?
Yeah. Yes, in TCP, they have acknowledgement, right? They send acknowledgement to calculate this one.
Oh, and this doesn't assume an acknowledgement.
Yeah. Right. They mock this way to do that, but TCP descending that if they don't get acknowledgement if we send the packet. But I think for this TFRC, they don't resend things. They just mark the way to TCP, not to make it to be TCP.
So they don't require, this protocol doesn't require feedback necessarily. You could be sending UDP packets all in one direction. And the receiver just periodically replies.
Yes, this is TFRC. This, I have to draw something. The part is not good, but this here.
Yeah, receiver.
So that receiver will periodically send the receiver report.
Right.
That is feedback packages to sender, and they calculate something at both ends, and then finally they got all the parameters they need, such as RTT and P, that loss even read, and give it all to the sender, and sender use that equation to calculate the sending rate. If that sending rate is higher than right now it reads, it's lower, it adjusts that rate to the calculated one.
Got it. Okay.
So RTT is simple, but for this loss event, as John said, it will have sharp oscillation or something, so it's use average loss in interval to do that. So it seems to be difficult, but if you're drawing something, it should be very simple.
It would be helpful if you are going to write.
Yeah, yes. It's very simple things. We have, so what it shows? It shows we have, this is time, right? And this is the sequence number. So with the time increase, the sequence number increase, we have something like this. We have a line. And if we say this is now.
This is sending at a fixed rate? This
Yeah.
is with sending at a fixed rate, right?
Yeah. And if I suppose this something is sending like this, and change it. And we have some packet loss. Suppose we have packet loss. So this is now right. What we have to make it different. So we will have this. This should be I1 because this is now this is I0, but this I0 is different from others. This one is ongoing.
Yeah.
Yes. It's ongoing, so we will address it later. So
Yeah, separate.
it's A1. And for this equation, it's really simple. See here, it just make the half n to be 1. I2, I3.
Yeah, just write really carefully. That's not scribble. Try to write your things really, really carefully. People won't be able to read that.
Oh, sorry.
It looks like Z's. Just write it really slowly and carefully. Okay, and what's that formula on the right? I can't read that either. The something squiggle over squiggle?
Yeah, sorry. Sorry about that.
It's fine, just write really carefully when you're, this is like a TFing 101, when you're a teaching fellow. It's important to write really carefully.
This,
Oh.
the half n, yes.
What's n?
This n is the interval that we want to in this.
There are n intervals?
Yes, in intervals. And
Okay, so write in at the bottom, just so we understand that.
Yes.
All the way at the bottom, right?
And in the RFC files, they recommended that this n no more than 8. I don't know.
So that's the last 8 intervals. Yeah, because of recency, because things change. I mean,
Yeah.
stuff that gets old, I mean, you either use exponential weighted moving averages or something to phase out the time.
So
I still don't understand. What's n over 2? N over 2, what's the units there? I don't get it at all.
n over 2 means the half of the interval.
Oh,
they make half of the interval with the same weight, and then the rest of the half with some changes, with some this equation, this weight. So this something they care about history. They make the most recent one with high rate. And with the later one with low rate. So this is this equation.
Okay, so I think I understand. So you're saying that the weights they attribute to these. Think about the weights that we put on.
Yes.
This is weight 1. This is weight 1.
Yeah.
Weight 1. This is weight 1. And then down here, this is the smaller weight.
Yes.
Something like a quarter.
Yes. Sure. 0.8.
So there's more weight ascribed to these intervals.
Yes. This we can draw here.
These are low.
Yes.
All right.
We can draw here something like this. Right. And we have a lot of intervals. And they have the same equal to 1 weight, and they have different weights.
Yeah. So this is all to estimate the loss probability. If we take our loss probabilities,
yes,
being emphasized from recent values.
And then we can use this weighted interval to calculate the average, right?
Yeah.
So go back to.
Oh, why is the screen inverted like that? It's all backwards.
Because we don't have a professional.
But it's a mirror image. Why is that? That's crazy.
So this equation is used for.
Mention the number, please, so people can follow along.
Yes, the equation 6. We can use equation 6 to calculate the average, right? This is average from 1 to n. But we want to also dealing with I0. So how to do this at I0? So we just, because it's ongoing, we just take it into this. This just calculate the 0 to n minus 1, and later we compare this to. If this one is max, then this means that I0 is greater than.
Okay, this is all details. I think we get the point. I mean, you can definitely weight the different loss intervals across some formulas.
Yes. So it's really simple, I think.
It's simple. It's still brittle, though. I mean, I think that we're still estimating something p, which is very hard to estimate, regardless of how we weight the recent intervals and the probabilities.
Yeah.
It's still not going to be an amazingly good estimate.
Mm-hmm. Sure.
Is there any work that has a mechanism to globally estimate speed?
Globally, what does that mean? Across a path?
Would aggregate information from more than one flow?
Yeah, XCP tries to do something like that.
Maybe seems we lost.
I think we're just project.
Yeah, I think another. Did we look at XCP yet as a possible candidate? XCP. There's a different congestion control protocol that uses more aggregate mechanisms. And maybe some in-network mechanisms as well. It might be a little more modern.
No.
That's one to look at.
I think that you should at least read the paper.
Okay.
So you have another point of kind of a new dimension in space.
Sorry. So can
we'll give the reference.
Send the paper to me and
sure.
Reference, because I'm not sure right now.
Just type it into the chat window, XCP.
The 3 letters.
Oh, XCP, right?
Yeah.
XCP, right?
Yes.
Okay, I know it.
Try to type it right into the broadcast window so people can see it. Into the chat window of this Hangout.
Okay.
It's by Dina Katabi. If you open the chat window, I'll type in a reference.
Do I have a group? Where's mine?
Well, I'll type right there.
Where's my group?
I can have it in this chat window.
Can you help me?
Yeah.
Okay.
That's my windows. I can't find mine.
XCP.
Yeah, so let's keep going there. Okay, great. Is there anything else here? I think we more or less covered it. But
yeah.
What else?
There's something called history discounting. It just calculate the I0 with the most weighted. So just
That's fine. That's like a technical detail.
Yeah.
I think we don't need to discuss that.
Yes, sure. We can skip that. We give this concept as optional if you want. You can.
Yeah.
You can take, because this TFRC it's slow to react to the decrease of the congestion.
Yep.
That's
slower than TCP.
Yes. So it's you're assuming you have a long time doesn't have package loss in the I0, and it will affect the whole procedure, right? So we need to give the most recent one the higher weight.
Yeah.
So this is described. This is just the simple one. I suppose if you're more than 2 times of the average, you can cut half of the old one.
Okay.
So that's it. So I have some project outlines. Maybe we should change it first, or can also in the meantime, I will also check this XCP protocol and compare if I have a new idea. So what I'm thinking is try to get this TFRC and then bring TCP principles to XIA. It's my idea.
It's fine. Yeah, I think acquiring the important parameters is relevant to figure out.
Yeah. Yes. So
I guess I don't really get share the same mathematical model for TFRC. I don't see why they wouldn't. So this goes back to Michelle's question. I don't see.
Yeah.
If we send packets according to TFRC, it's going to obey the mathematical model for TCP.
Yes. I also think they're the same.
It's not a matter of being the same. I'm saying that
Yeah.
if we follow what TFRC does, we therefore follow the mathematical model for TFRC.
Mm-hmm.
I don't see I don't get the question. There's something wrong about the question.
Okay.
In my eye. If XIA over XTP applies the formulas in TFRC, it will share the model for TFRC.
Yeah.
There's nothing to verify there.
Yes, I mean that. Is there some chance that I mentioned previously that throughput equation is not?
Again, if you follow the prescription of TFRC,
they're the same, right?
it is going to be TCP friendly.
So okay, we can.
It doesn't matter what. The only thing that's the packet contents are going to be different, but all the relevant parameters. I guess the TFRC equation is protocol agnostic. It's saying any protocol, no matter what it is, that follows these rate-based equations, will be TCP friendly.
Okay.
It's like a theorem.
Okay.
So it applies to XIA, it applies to foo, it applies to anything.
Yeah. Yes. So,
yeah.
And the third one I mentioned is unicast. So how about to manage multicast?
Yeah.
Multicast, they also have some RFC to show how to implement the multicast.
Mm-hmm.
So this is the questions when we address the multicast. For example, how to address the feedbacks reports. There will be a lot of receiver to send this feedback to a sender, right? And there also we will calculate a lot of sending route and which sending route we choose.
Yeah, that's a much more complicated question.
Yes.
I think we need a good, compelling multicast case study, which we'll have.
Yeah.
Video will be an example of that, but we should do that before we solve multicast.
Yes. So and the last one is that, as Michelle told me that we need, if we want to test this idea, we use a user and something to test it in the lower development cost, right? Yeah. So we don't want to depend all and then prove it's not good. That's right. So it's possible dependencies, or I mentioned that the wealthy and life maybe some dependencies we want, and the implement and user land code and related is later we want to bring global congestion to XIA. Maybe the first attempt. This is a Kickstarter for us to thinking about the global congestion control, right? This is our first attempt to do some congestion control on XIA. So later, there's some desirable outcomes. So what we want to bring to XIA is TFRC mechanism and TCCP-like principles, and the kickstart to global congestion. And further work, I think we like to propose and implement global congestion control. This is all the reference I agree. So
okay, great. This is a really good proposal. I really like what you proposed, and both the proposal itself and the document.
Yeah.
That looks good.
Okay. So and this is my today's talk.
Great.
Thank you.
Thank you. Cody, any questions on your end before we?
Yeah, I do actually. I was saving them till the end here.
Okay.
So these aren't meant to be questions that can be answered, just kind of throwing them out there. But I was thinking first that we have to be. This reminds me of how we, or at least Michelle, thought really hard about how NWP should be brought into XIA. So whether it should be coupled with another principle, whether it should be its own principle, whether it should be inside XIP, and eventually decided that it should be kind of a companion to the HID, right? And the reason I bring this up about congestion control is that at least the way I'm thinking about it, it's really easy to imagine congestion control in the IP world, right, between two hosts. But when you start to talk about adding congestion control on top of content-based routing or service-based routing, then you have to worry about, then you have to think more about the content and services as an abstraction above the host, because at the end it's really with the host that you're communicating with, right, to figure out what the congestion control should be. So it's just another layer of complexity that I'm not sure how to think about.
That's a very nice observation. I think that we should see if there's work that is thought about congestion that does not follow the abstraction necessarily of, I guess TFRC assumes a path between two endpoints. It doesn't have to be hosts, but it does assume that there's kind of a logical path that over which you're computing these values P and RTT.
Yeah.
So that's what's breaking, I think, in the model you're thinking of.
That's true, and this is really only applied to flows, right?
As opposed to multipath?
Yeah, like this wouldn't. We wouldn't want to apply this on top of something like Z-filter. So a lot of other interesting questions is how do we combine this with other principles, I guess. So for example, if we had services and we need to migrate the service, we need to make sure that the transition with the congestion control goes smoothly. Or for something like Z-filter, we probably don't want congestion control and multicast, right? We want to rely on other things like the erasure codes that we've done.
No, we want congestion control too, because multicast can't just go untrammeled. Just because it's reliable doesn't mean it can go as fast as it wants. There's extensive literature on I worked on it too, on multicast congestion control. It's a really interesting problem. It's a really hard problem because you need to congestion control, even if you take the idealized view of the multicast being a tree, you need to set different rates across different parts of the tree. You don't want the crying baby problem where you go as slow as the slowest receiver. Right. There's feedback implosion. There's tons of different problems you have to deal with congestion control. But there's good work. There's good work even using TFRC where you treat each segment of the tree as somehow an autonomous part and quench different subtrees at different rates. So you can still go fast along subtrees and quench other parts of the tree to go slower. Combine it with layered video coding or digital fountain style reliable transmission and get some pretty decent solution.
Right.
provided you solve some pretty hard problems along the way with congestion control.
Okay. Yeah, no, that's interesting as well. And finally, I was thinking, is this really just a control plane solution, or is this a way to somehow, if we could couple it with data plane packets, for example, to have multiple syncs? So not just that I want to retrieve this content or I want to talk to this host, but also my intent is also that I want to use rate control. So would that be like a second intent or somewhere we could use multiple syncs?
The feeling that I'm getting from your questions is that the questions that you are asking are more focused on how we have this global congestion control.
Mm-hmm.
What I do like about, by the way, the questions, I think the questions are well thought. But I also understand that the Yuguang proposal, it's something smaller. Is just having TFRC on XIA so we can learn something about congestion control on XIA, in XIA context. But I think your questions are pretty good, and I think you should even take notice of those questions because they may guide you to what kind of thing you should be reading.
Sure.
Or even be a Kickstarter for a future project about global congestion control.
Can we ever contact Cody and get his questions and see about that?
Let's capture these two questions because they're really, really good ones. One is specific to TFRC and one is not. The first one was, where does TFRC congestion control reside? Some IID types want to inherit that, like host-to-host communication, once TFRC, or maybe even, content. I think content does too, provided it's along a path.
Yep.
And maybe even services, but that's less clear. But the question really is, how do you inherit TFRC into a principle that wants to use congestion control? It feels most analogous to me like multiple inheritance, but we don't really have that concept. But we do want to place congestion control somewhere that it can be leveraged by multiple principles. I don't see offhand how to do that right away. Maybe Michelle does.
I don't. It's not. When we set up the global congestion control goal, it was because it wasn't clear how to do it, how to go about it. I mean, we could implement some prototypes, but which one would be better, or even how to evaluate them, it's not clear. That's why it's a research goal.
As Cody, this question is just one of them. I send you my draft, right? I paste some questions there. I just think about, so how do we define this host to host or principal to principal? How do we define the RTT between the host or the principal to principal?
Well, if you have a destination address and a source address, you can measure the RTTP.
Yeah, I think TFRC really is not host-based or anything like that. It's really path-based. TFRC is thinking about the rate across a path from one place to another place, regardless of what type of communication is, whether that's service-based, host-based, who knows what based, but it relies fundamentally on a path. So that's what Cody's first question was that. And then Cody's second question is also a very good one. It's a little bit more complicated. I think it relates more to global congestion control. Do we have some kind of opportunity in a very highly evolved world where a principal communication may take unexpected forms? It may not be along a path, might be along something that flutters or changes, could be along multiple paths, could be along a tree, could be across a Z filter. Do we have any chance, realistically, to build a congestion control protocol for XIA that always works? I think it's a really good research question, and it may circumscribe the extent to which XIA is evolvable, because maybe there are situations where we really don't have any chance of, or no hope of, defining a reasonable congestion control protocol over something that's highly ephemeral, highly changing, and while we could define it in XIA, we might not be able to control it.
Right. Very eloquently put.
Or or the counterpoint to that is maybe there's a whole set of things that we can control, and we can circumscribe what those are and put those into the realm of working with whatever this global congestion control protocol is.
Right. Yeah, so I didn't intend for those to be answered, just throwing them out there. But yeah, I think we should discuss it more as this project evolves.
Totally agree. I mean, there's question 2 is both questions are a little bit separate from this project. Question 1 is about how does congestion control writ large integrate with XIA, and which applications can inherit it, regardless of whether we adopt TFRC or something else. And question 2 is very broad. It says how do you define a congestion control for an architecture that takes many forms, like XIA, and evolves?
Right. That's all I had.
Those are great questions.
Thank you.
This later part of the meeting was reserved to at least saved for the GSoC students. We have one viewer. If you can write your comments so I can bring your questions up. We are going to try to answer as many questions as time allows now.
And it's not a requirement. We can take questions offline, or you don't even have to ask questions, so we can just send.
Yeah, that's true.
You can message either the mailing list or Michelle directly.
There were some questions posted. Did you guys see those?
No, not in the group chat. Where are the questions posted?
They're on the like the broadcast Hangout page on Google+. I can copy and paste them too.
I cannot read from here, but you can read it then.
Sure. Well, maybe I should just copy and paste.
Okay, that's a little out of scope for this talk. We'll address that one offline. It's a question about the LPM principle.
Oh, no, I think it's a fair game because it's about the projects that for GSoC.
Okay, that's fine. Are there any other questions? Cody, or is that the only one on there?
I just copy and pasted another one.
Okay. Let me read from here.
Okay, I'm going to take my leave. I'll see you guys.
Okay.
Great talk, everyone. Really good.
Yeah.
Thanks.
Talk to you later.
The question is being asked by Gamal. I hope it's not too wrong. It's about how he could evaluate the LPM, one prefix match principal, and he is proposing it's a framework NetBench. I don't know NetBench enough to answer this question. So if you know it enough and think it could be used for assessing LPM, it would be a valid suggestion. But I really don't know the NetBench. It could be proposed that if you are aware and you know it could be used, you should write your proposal as the way you are proposing to make the evaluation. If you don't know if it could be used, your proposal could mention it as something that you would need time to verify if it could be used or not. If yes, it would be fine to use. If not, you would still need to come up with something to do the evaluation. I hope it answered your question. Do you have more questions, Cody?
Nope, I don't think so.
I think that concludes our meeting. Do you have something to bring, Toby? It's not required. I'm just asking if you have something to say.
Yeah,
before
I have a question.
Sure.
So, what's the cost? To bring the TFRC to XIA?
Bring?
Yeah. Actually, I also have a question similar to the first question from Odin.
Okay.
Yeah, where should we put the TFRC principle?
Yeah.
On the host or on the middle of the
Yes.
the path?
About where to put it in a global sense, I don't think we have the answer.
Yeah.
And at least for the first steps that he was proposing, he will do whatever he needs for verifying how valid his idea is. Maybe in the process he will figure out how to grow the solution, but at least what he's proposing now is just to, if we get this path, can we measure it? Can we make good use of it? Does it make sense to follow it? Because, for example, he will read the XCP paper.
Yeah.
He may figure out that it would be an easier way to go instead of. I mean, he is not. He is at a very early stage of the project, so he doesn't know that answer.
Yes, this is just a preliminary. We are just want to show your guys. I even don't know it is feasible or not.
Yeah, right.
Because I have this idea. I had some experience and research about read controls. I contact TFRC previously, so I'd like, this is something I'm familiar with. So I'm not familiar with ICP. If I know ICP, maybe
XCP.
XCP, yeah. I may talk XCP to bring XCP to XIA, right?
Okay.
It's just idea to get all your feedbacks.
Yeah, but that's the idea of this meeting, is to present and get feedback.
Yeah, that's good. I got a lot of good questions about this, and also have an extra work to do, XCP, to read that, right?
So can you introduce the cost briefly? So here, because I didn't see the cost.
What are you calling by cost?
Maybe
The effort to implement, or just something else?
maybe it may degrade the performance compared to other protocols like TCP or UDP.
Could you formulate what cost mean in question? I still don't
So
get
I
it.
think Chubby's idea is, if we bring this to XIA,
Okay.
will it degrade others?
Oh, if you are. But then when you talk about degrading, you assume that these are not the congestion control. We still don't have that in XA, so we cannot be degrading nothing.
Yeah.
If the nothing is empty, empty set. I think that reframing the question, if we adopt TCP friendly globally in XIA, what would be the cost for another congestion control protocol? That now I make sense of the question. Does it kind of extend correctly your question?
I think so.
Okay. Now with this question, I can answer. You remember in this meeting I told you that there are more than one way to go about TCP friendly. We may decide to make it global for XIA as a decision, as a design, something that we will kind of push. But it's not clear why or if we should do it. We could just for now assume that there is no congestion control for this XIA, and so they have to find a way to interoperate. And once we have a connection to TCP, a bridge for IP network, then you would need a solution to bridge whatever XIA is doing to something that is TCP friendly. So to answer your question, the cost now, at least, is zero because there is nothing to punish or to make worse. But to reframe your question is how we justify embracing something that is TCP friendly global. I don't know the answer. I don't know if if we are ever going to make this answer, or if the answer will emerge from our work, or if the answer will be something else. I don't know. But at least now the cost is 0 because there's no one to punish. At least for now.
Yes.
But yeah, that's a good question. If we don't have more questions from the students, we are going to finish this first Hangout on air. Okay, thank you very much.
Thanks, guys.
See ya.
See ya.